Point of day one, and to anyone who's just joining us now for the afternoon, we're so happy you're here. I'm Abhi, Staff Developer Advocate here at Google Cloud.
And I'm Turajo, Developer Relations Engineer. It's been an amazing start of day one of our onboard edition.
And the energy has been electric so far. I'm still thinking about May's customer agents demo, a fully functional agent with hardly any code. Wow.
That's incredible, right? So how fast things are moving is like really amazing. And Wei Liang and Natasha's Gemini Pro Live Lab really brought that to life. So with the reasoning capabilities, it's really proved the power of our most versatile AI model to date.
And we hope you all enjoyed the opportunity to get hands-on. We've also been keeping an eye on the chat, and the questions are rolling in. Keep them coming. Ask some architectural questions, deep dives.
Yeah, and we have a couple of quiz questions so far. So let's take a look at how you did it.
Which component of Google Gemini Enterprise platform enable users the access to Google's most advanced multimodal AI? What do you think?
Could be the brain, you know.
Yeah,
Let's take a look. All right. Yeah, most of you get it right. Great job. And the second question is, what are the reasons why you would combine keyword search with the semantic search? What do you think, Abhi?
I know the answer, but yeah, let's see if the audience have got it right. I think it's to cover keywords the embedding model doesn't understand.
Let's take a look. You're right. All right.
Yeah, the audience got it right too.
Yeah, this is crazy. Okay, let's do it.
We have a couple more questions coming up across this afternoon sessions, so keep your eye out. But for now, let's dive into what's coming up in the second half of a day. I hope you're all ready. We've set the stage with the agent ecosystem, but now it's time to get down to business.
That's right. So the first half is about designing the agent, but for this afternoon, it's all about deploying it. So we will start with the essential developer tools, and then the infrastructure you need to actually run this workload.
Kicking things off with Cloud Run, Andrew will look at how to unlock generative AI. Then Chandrika will follow this up with a deep dive into building complex
Technical series event. And if you need any extra direction, any help, check out this participant guide that is available for you in the resources tab at the top of your screen.
Awesome. Can't wait. And finally, stick around until the very end because we are wrapping up day one with a highly anticipated Ask the Experts session. We are still taking questions in this chat, so make it meaningful, make it count for you. And if anything comes across to your mind this afternoon, feel free to drop them in there.
Yeah, so for now, we will take a quick break to let you stretch, grab a coffee, and reset your brain. If you have any extra time, you might also want to check out this additional learning opportunity that we have included for you during the break time. So one of these, our brand new initiative, Gemini Enterprise Agent Ready, formerly known as Gear, and more. But don't worry, we will also chat about this in the next step at the end of the day as well.
We'd appreciate also if you could let us know what you thought of the onboard program from here within the platform itself. We truly take all your feedback to heart and use it to build even better learning experiences for you.
Okay, so that's it for now. We will see you back here in about 5 minutes. Let's start deploying.
Hello, and welcome everyone to these sessions. My name is Andrew Dole, the technical lead from the application modernization team from Google. In the next 20 minutes, I will be gladly introduce to you our latest development for Cloud Run and how you can deploy and serve your AI applications using Cloud Run in just few minutes. Okay, so let's start with a quick introduction of what Cloud Run is. And probably the best way is to position Cloud Run among family of other services that Google Cloud provides to our customers for an end-to-end development lifecycle of an AI application, from ideation to data preparation to development, deployment, running of your applications, and even day two operations. So zooming to these services that help you to run your applications, Cloud Run is one of the popular options, such as Compute Engine, or GCA, or Container Platform, or GKE in short. So these services enable you to deploy and run your AI application in a scalable and secure manner. A deeper look into Cloud Run. This is more of a fully managed and serverless service where Google takes care of the setup, configurations, and maintenance operations. So you simply provide your code in either a container or functional format. We will then run your application and then scale the needed resources according to the demand of your applications. So why should you use Cloud Run? As a fully managed and serverless platform, Cloud Run takes care of most of the operational tasks for you. So you can just focus your precious resources on your code, the actual differentiator for your business, and less on the infrastructure, which has become the level field for all competitors. So by uploading these non-value differentiating tasks to Google, you would then be able to achieve 95% faster in deploying your applications. Cloud Run also provides resources with redundancy by default. This means the infrastructure reliability is set up and maintained by our SRE team from Google. The resources from Cloud Run are auto-healed if there are issues, which help to minimize application interruptions by 98%. As the serverless platform, Cloud Run scales the resources up and down, matching to the demand of your applications. Especially, Cloud Run scales down to 0 when there are no traffic. This means you can optimize costs to exactly what your application needs, estimated to be around 15 to 50% less than the platform that otherwise you would need to provision and manage yourself manually. So in 2025, Cloudrun announced support for GPUs. So with all the benefits of a serverless platform, including fully integration to other popular AI development platforms such as Vertex AI and database platforms such as AlloyDB or CloudSQL, makes Cloudrun the ideal runtime environment for AI application development. So while Cloudrun had been known to be simple and suitable for many event-driven workloads, there is a lesser-known fact that Cloudrun is not only safely secure and maintained by our famous Google SAE team, but also can scale to enterprise-grade level. This makes Cloudrun also a suitable platform for diverse enterprise-grade workloads. We also announced the consolidation of Cloud Function to be under the same family of Cloudrun. This makes Cloudrun the one-stop option for all serverless applications, be it in a container or functional format. This also allows Cloudrun to support large variety of languages, framework, and libraries while stays open and portable. This makes Cloudrun actually the go-to platform for many application developers. So with the design philosophy of being open, Cloudrun allows you to run a large variety of AI applications, be it the model that you develop yourself, or an open source model, or the model that you have just fine-tuned from a foundational model. So Cloudrun provides multiple approaches for you to download and make these models ready for your application to load and serve. So while Cloudrun has been designed to optimize costs by scaling down resources as fast as possible when the traffic reduces, we have also been improving our platform to spin up new resources as fast as possible. So our benchmark tests show that Cloudrun scaled from 0 to an instance with GPU and needed drivers installed in 5 seconds. This is crucially important to keep the customer experience in high quality. As a developer-centric platform, the ability to spin up resources quicker makes Cloudrun a very friendly platform for quick experiments, which has been a key for successful AI applications. Comparing to other container platforms, which may take up to 20 minutes to provision, Cloudrun can do the same in minutes. This makes rapid tests possible and improve the development productivity by multi-folds. So in this session, let's explore practical reference architecture that our customers are using Cloudrun for their AI applications. And you can follow the same best practices for your own applications. We'll be looking at 2 commonly used design patterns for serving AI application on Cloudrun. On the first pattern, Cloudrun will be used as an entry point service for all requests. Cloudrun then routes the request to the backend LLM models hosted outside of Cloudrun. Popular options for these backends can be either on Vertex AI or Cheeky, or basically any reachable endpoints of your application elsewhere. This pattern provides the abstraction of the backend, provide you the flexibility to switch between different platforms for the backend if needed. On the second popular pattern, Cloudrun is used for both serving as an entry point and hosting the application itself with the new GPU support. In this pattern, you will be able to utilize the unique support of Cloudrun, a serverless container platform, for AI application utilizing GPU today. This pattern provides the simplest architecture where both components are hosted by Cloudrun, providing the benefit from flexibility, control, and cost optimization end-to-end. So, given Cloudrun with the GPU support, this actually opened the possibility for you to build and run a variety of AI applications. Let's explore popular use cases that our customers are building. First is real-time multimodal inference. So for example, imagine you want to run a chatbot application for your end users, but at the same time, they want to generate images using text prompts. So your chatbot should be able to support both text and image generation. You can also use Cloudrun to deploy AI agents. Take an example where you want to run an IT support agent or customer service agent to autonomously answer your users' questions. Cloudrun GPU service can also be used for non-AI compute-intensive workload. such as media serving for your videos, audio, or image files, or even 3D rendering for game development. If you are looking on the slide, on the right-hand side, you will see Cloud Run jobs. This will not be covered today. However, at a very high level, for use cases where you need resources for a longer periods of time, such as a small-scale model fine-tuning, training, or batch inference, or simply accelerating background tasks, Cloud Run jobs offer a simple and cost-effective option for these use cases. So now, let's deep dive into a use case which is the talk of 2025 and will continue being the focus of our customer in 2026, AI agents. So among other options, Cloud Run provides the simplest and cost-effective option to host your AI agents. Cloud Run can host a scalable and reliable serving and orchestration layer. And at the same time, it can integrate with multiple needed backend services, such as the core AI model, which can be either Gemini API or the model endpoints from Vertex, GKE, or Cloud Run itself. Cloud Run also supports integrating with the needed memory store, vector database such as Cloud SQL or AlloyDB, and any other required tools to develop your AI agent. Cloud Run also supports LangGraph and Agent Development Kit, or ADK in short, which are popular solutions to develop AI agent applications. So along with simple operations, Cloud Run with NVIDIA GPU also offers strong performance. We keep our infrastructure latency to a minimum so that you can get the best performance while serving your models. The table on the slide show cold start times for multiple models with the Ollama framework, ranging from 11 to 35 seconds. This measures the time to start an instance from zero, load the model in the GPU, and for the model to return its first word. So, being the serverless and fully managed service offering, Cloud Run makes it absolutely simple for you to deploy your applications. It adds a couple of clicks on the console and a single checkbox to enable GPU support, or through the programmatic approach, such as the YAML file or the gcloud command on the terminal. So, in the next sections, let's have a quick look at a customer right from this APAC region who has been successfully utilizing Cloud Run for their AI application. With Cloud Run GPU support, Vivo had been able to experiment multiple AI applications with quick iterations, with multiple models and multiple deployments within a day, allowing Vivo to quickly identify the application that works best for their customers. Vivo gains the greatest benefit of Cloud Run in reducing the operational and maintenance costs, which allow the team to focus more on the application itself. The ability to scale fast and scale to the great enterprise level improve the performance and reliability of the application, enabling Vivo to expand their business overseas efficiently. In the next section, let's see Cloud AI application in action through two demos. So, in this first demo, let's have a look at the reference architecture of how Cloud Run can be used to generate image. In this architecture, we will see that there will be a Cloud Run instance with L4 GPU. And in this architecture, we're going to use TorchServe, which is the serving layer of the architecture. And for the model itself, we're going to utilize Stable Diffusion XL to generate our image. All right, so let's have a look at what I needed to build our application running on Cloud Run. First thing, because this is a Python application, so we're going to have a requirements text file. And in this requirement text file, we are having the necessary libraries, especially if we are looking at the transformers and the diffuser, which are basically the models that we are going to use to generate our image. We're going to also include the libraries so that we can interact with cloud storage to save our image after it's being generated, and also the necessary library to interact with NVIDIA GPU. This config property file basically contains the parameter that required for our applications. For example, the port that the service we're listening on, as well as other parameters defining the number of workers that is going to be needed for our model. Moving forward, this is basically a very standard Docker file to generate the container image. In this, you will be able to see that we have a section to download the model, and then we also archive the model into our cloud storage, basically copying over the property file and also the Python code that we're going to go to in just a little bit. This is basically the logic of the applications, right? Our Python code. In this Python code, we basically receive the text prompt, and then we transfer that and then feed that into the models to generate the image. In the logic to generate the image, there are actually two main steps. First step is going through an API, which is a pipeline to generate the first image, the draw image. And then we're going to utilize the second API, which is a refiner, to actually fine-tune, refine the image that was generated in the previous step. So very simple. After we generate and refine the image, we're going to return the image back to the caller. All right. So the way that we're going to build the container image is very similar to any other container platform like Jiki or Cloud Run. We're going to utilize the build command to generate the image, and then we can just run the deploy command to deploy our image to Cloud Run. To speed up the time for us, in this session, I already have the service deploy and is running at the moment and ready to serve our request. And if you paying attention to the below panel, you will see that we just specify the variable service URL to the service that we just deployed, and then we prepare a prompt text with that we want to generate an image of a dog running in the park, and then we can measure the time for the service to actually generate the image. And in this demo, you will see that it took 16 seconds for the image to be generated. And after the image generated, we'll be able to verify it. It actually saved into cloud storage itself. And you see, we have the image of the dog running in the park exactly to matching with our request text prompt. In the next demo, I want to demonstrate to you the ability for Cloud Run to scale. This is, as I mentioned in the previous slide, the less known fact, right? So in this case, we're going to scale the number of clients from 0 to 100, and we're going to observe how Cloud Run actually scale the needed resources, in this case, GPU instances. So if you are paying attention to the middle of the screen, you will see that while the number of load generator client increase, the number of GPU instances also increase accordingly to ensure that we have enough resources to serve the request. Also pay attention to the middle screen where we show the number of images generated per second, as well as the latency for each image to be generated. As you can see, while the number of clients increase, the number of GPU instances increase, we also increase the number of images can be generated in a second. And at the same time, the generation latency also start to go down. This means we will be able to provide more resources to generate more image per second, but at the same time, improve the performance by reducing the latency to generate an image. So in just a little bit, you'll be able to see that in around 4 minutes, we would be able to increase the number of instances from 0 to over 100. And then it crossed 100. right? So what can we learn from this demo? Basically, while we are receiving more and more load from our clients, Cloud Run will be able to scale to hundreds or even thousands of GPU instances in just minutes. It may take other platform a good 20 minutes to just provision one VM, right? Or the one cluster. And at the same time, the number of images per second and the latency metrics are also improved. All right, we have reached the end of our demo. We also have additional resources that can help you to build and deploy your application quickly and efficiently on Cloud Run. So please scan the QR code below to find those links in the detail. So that's our quick introduction to Cloud Run, and with the support of GPU, Cloud Run provides the developer-centric platform for you to quickly deploy and run your AI application in just a few minutes. I hope you have learned a few new things from these sessions, and we are looking forward to your feedback to continue to improve our content to be better. Until we meet again, thank you and have a great day.
We are moving from simple AI models to agentic systems that can reason, plan, and execute complex tasks on your behalf. This is a significant advancement that is unlocking new opportunities for innovation. Hello everyone, my name is Chandrika Kadirvelmani, AI Principal Architect at Google Cloud. In this session, we will provide you with a comprehensive guide to building the powerful agentic AI applications on Google Cloud. An AI agent is an application that attempts to achieve a goal by observing the world and acting upon it using a large language model and the tools that it has at its disposal. So how does it work? At its heart, building an AI agent is all about connecting a powerful AI brain like an LLM to the tools it needs to get a job done. These tools can be your company's APIs, your internal data, or even other specialized agents. To set one up, you first teach it what you want it to do using plain English instructions and a few examples. Then you give it a memory so it can remember context like your past conversations. Finally, you teach it how to plan, how to break it down, a big complicated goal into smaller manageable steps. And that's all. Once you put all that together, you have a functional AI agent. You can ask it to do something complex and it will start working on it in the background. It might go through a dozen different steps on its own before it responds, like delegating a subtask to another agent, looking up facts, or even popping back with quick question to clarify something within you. But as developers, let's translate that into a code. What does this actually mean for us? A standard call to an LLM is a single stateless transaction. You call a function like, for example, model.generate_content. You send a prompt and you get a response back. It's a simple request response. An agent in terms of code is fundamentally a loop built on top of that API call. It's not just any loop, it's a reasoning loop. This pattern is often called the React loop, like reason and act. It looks something like this pseudocode. The loop continues as long as the user's goal isn't met. Inside the loop, we first enter the reason phase. We ask the model, give everything we know so far, what is the next logical step? The model might respond with the final answer, or it might respond with the request to call one of our tools, like a function to look up a stock price, for example. This brings us to the act phase. Our code checks the model's output. If it's a tool call, we pause, execute our own Python functions, take the result, and add it to our context or state. Then the loop repeats, sending that new information back to the LLM for the next reasoning step. So here's the key takeaway for the developers. The LLM is the brain, but the agent is the loop. It is the orchestration code that turns the LLM's reasoning into a series of actions. Now, looking at the loop, you might be tempted to just write it yourself. But as you build, you hit the same hard problems everyone hits. You have to manage state and memory. You have to write fragile code to pass the model's output to see if you want to call a tool. You have to figure out how to orchestrate workflows when agents need to talk to each other. And you end up writing the same boilerplate plumbing code over and over again. This is the exact problem a framework is meant to solve. And that's where the ADK, the Agent Development Kit, comes in. The ADK is an open source framework that designed specifically to handle the complexity of that reasoning loop for you. It provides the structure and tooling to manage state, handle tool calls, and orchestrate agent collaboration, letting you focus on the unique logic of your application, not the plumbing. It gives you the building blocks to create agents that are capable, autonomous, and even work together. When you start building with LLMs, you have several options for how to approach it, each with different level of abstraction. At the lowest level, you have the DIY approach using direct REST API calls to the models. This gives you maximum control, but requires you to handle everything yourself. Moving up, you have low-level LLM framework like the Google Gen AI SDK, which simplify the process of calling different models. They come the low-level orchestration framework like LangChain, which help you chain those calls together into simple workflows. The Agent Development Kit sits at the level 3, providing a true agent framework. It handles not just the calls and orchestration, but also the more complex agentic capabilities like the state management, planning, and multi-agent collaboration. ADK is designed to give you the power of high-level framework while keeping the development process transparent, and manageable. Once we deploy, we need to give access to the, Once we deploy, we need to give access to the users. Without a standard, we face a fragmented experience. Every agents end up with a different custom front end, creating a disjoint user journey. This leads to integration nightmares where we waste time building boilerplate code and governance gaps caused by unmanaged access across scattered apps. Gemini Enterprise solves this as one portal for all AI agents. It acts as a seamless bridge separating the backend brain from the front-end face. In just 4 steps, deploy, create, app, register, and launch. Users can immediately start conversing in a secure, polished interface. No front-end code required. We can build complex, code-heavy agents on the Vertex AI and simply register from here. This unlocks open orchestration, meaning our agents can collaborate. It also provides centralized lifecycle management to update agents instantly, all while enforcing the governance, which is crucial for an enterprise. So this, whatever I explained, right, comes at the end. So we are just going back to the ADK. ADK is a software framework designed to simplify the creation of multi-agent applications. So the Dev UI provides a graphical interface for developers to build, test, and debug the agent. The tools allows you to easily connect your agent to thousands of tools, APIs, and data sources. It allows you to combine deterministic logic with the Gen AI capabilities. This ensures your agent is reliable, testable, and safe, and is very important in an enterprise context where you may need to be 100% sure that you get predictable outcomes. So it is model agnostic, supports any generative model, and it is optimized for Gemini as the default. And you can use it for a wide range of use cases, including not only your typical chatbot type solution, but also agents that perform tasks in the background, and also multi-model agents that use streaming audio or video. Let's get into the code concepts. The core of ADK is the base agent class. We provide 3 primary categories of agents you will work with. Let's start with the LLM-based agents. These agents use a large language model as their core brain. They leverage the reasoning and evaluation capabilities along with a set of tools to determine the best course of action to achieve a given goal. Second, we have a workflow agent, the orchestrator, which executes tasks in a specific order, much like a traditional software workflow. As you can see, these workloads can have different execution flows. They can be sequential, run in parallel, or use conditional logic to make decisions or operate in a loop for iterative tasks. Finally, we have custom agents. This category represents a more hybrid approach, combining custom logic and code with the power of LLM-based components. This gives you the flexibility to build highly specialized agents that are tailored to unique or complex tasks. The most fundamental building block in the ADK is the LLM agent. Think of it as the brain. You define it with 4 key properties: a unique name, the model that will do the thinking like Gemini, a description so other agents know what it does, and most importantly, the instructions. The instruction is the detailed prompt that tells the agent who it is and what its job is. Getting this right is the most critical skill in agent development. Technically, a tool is typically a modular code component like a Python function or a class method. To equip an agent with a tool, you simply pass the tool into the tool's argument during agent creation. We'll see more on tools later. So meaningful multi-turn conversations require agents to understand context just like humans. They need to recall the conversation history, what's been said and done to maintain continuity and to avoid repetition. The ADK provides structured ways to manage this context through session, state, and memory. Session is the current conversation thread, represents a single ongoing interaction between a user and an agent system, contains the chronological sequence of messages and actions taken by the agents referred to events like during that specific interaction. A session can also hold temporary data that is relevant only during this conversation. State is used to manage information relevant only to the current active conversation thread, example, items in shopping cart during this chat. Memory represents a store of information that might span multiple past sessions or include external data sources. It acts as a knowledge base the agent can search to recall information or context beyond the immediate conversation, which is managed by a memory service. Beyond just storing data, robust agents need structured ways to record actions, manage files, and allow you to intervene in their logic. ADK handles this through events, artifacts, and callbacks. So an event in ADK is an immutable record representing a specific point in the agent's execution. It captures user messages, agent replies, requests to use tools, etc. An artifact in ADK is a managed resource representing a specific file or binary object associated with a session. It could be any PDF document or generated images or audio files, anything like reports. A callback in ADK is a developer-defined hook that representing a specific intervention point within the agent execution lifecycle. It enables the injection of custom logic at critical moments, such as before a tool runs or after a model replies, facilitating the task like logging safely, validation, debugging, and external system. But how does ADK coordinate all these components together? Like, think of the ADK runtime as the engine of your agentic application. You define the parts, agents, tools, and the runtime handles how they connect and run together to fulfill a user's request. The runner receives a user query and asks the main agent to start processing. The agent and its associated logic runs until it has something to report to, like a response or a request to use a tool or a state change. Then it emits an event. The runner receives that event, processes, and any associated actions like saving state, and towards the event onwards, example, to the user interface. Only after the runner has processed the event does the agentic logic resume from where it passed, now potentially seeing the effects of the changes committed by the runner. This cycle repeats until the agent has no more events to yield for the current user query. In event loop is the core operational pattern defining the interaction between the runner and your custom code, like agents, tools, callbacks, collectively referred to as execution logic. You can run your ADK agent with an interactive command line interface using the ADK run command or the ADK web user interface that is shown in this snapshot. And you can view all the components that we have so far discussed here. So this gives you a very easy debugging during your development phase. Next comes the tools. A tool represents a specific capability provided to an AI agent, enabling it to perform actions and interact with the world beyond its core text generation and reasoning capabilities. ADK provides a rich ecosystem of tools, like it has pre-built Google tools like Google Search or Vertex AI Search or RAG. And we have integrations for popular third-party libraries like LangChain or Crew AI, but the most powerful feature is the custom tools, because you can turn any Python function into a tool, right? But why you all need a framework? You can just go and write your codes, right? The answer is, if you don't have standards, we end up in a spaghetti junction of custom integrations. So let's start with the first one, the Model Context Protocol, or the MCP. So MCP is an open standard serving as the API spec for the AI tools. It connects agents, that is the clients, to the tool servers by standardizing two key actions: the discovery, like what tools exist, and execution, run this tool. Think of it like a REST API for agents, simply replacing GET and POST. ADK integrates with MCP using a standard producer-consumer pattern. As a MCP client consumer, your ADK agents connects to an existing MCP server to instantly access external tools like databases or API, and it can be streamlined through a single class like MCP toolset. By simply adding it to your agent's tool list, it automatically handles connection, discovery, and execution behind the scenes. There is no complex setup. Just initiate this class, and you will agent instantly gains full access to the server's remote capabilities. ADK also simplifies the reverse, that is exposing your tool that as a MCP server, that is a producer. You define your logic using standard function tools and ADK utilities and automatically translate them for the MCP server. This setup acts as a bridge, seamlessly converting incoming MCP requests into native ADK tool executions. MCP defines the language, but we still need a transport for the wire. There are two primary connection methods. The first path is the standard I/O. That is, this is for your local development. It runs the server as a sub-process, but it doesn't scale, right? So for production, you have to use the HTTP network, which is the standard, and your agents connects to a standalone service via URL. This provides high scalability. So next, we have seen the power of MCP, but if agents can simply expose their skills as tools, you might ask why we need a specific protocol for them. The answer lies in a critical distinction: agents are not tools. So let's look at why it matters. Agent interactions are fundamentally different because they are unbounded and conversational, allowing for back and forth clarification and autonomous background work. This is where the A2A protocol comes in as the open standard for agent collaboration by using agent cards for discovery and standard web protocols like HTTP for communication. It enables independently built agents to find each other and delegate tasks and coordinate effectively on complex goals. So how the life cycle of an A2A interaction happens, right? The flow moves from left to right, starting with the user interacting with a client, which sends a request to agent A. Agent A then connects to agent B, which is the remote agent. A critical concept here is that the client and remote agent are just roles, not fixed identities. The system is designed for collaboration. For example, if agent B needs extra data to fulfill a request, it can switch roles and act as a client to call a third agent. But before any interaction happens, we need discovery. This is handled by the agent card, essentially the agent's digital business card. It's a standard JSON file, and that defines the agent's identity, endpoints, authentication, and specific capabilities. So once connected, the conversation begins, and the first message agent A sends the object containing paths, which can be text or files or JSON. While we usually use the HTTP REST, the protocol is transport agnostic. If the request is complex, we don't want to block the connection. Instead, the backend managed by the agent executor creates a task, and agent B immediately returns a task ID and status, allowing the client to track the life cycle from submitted to completed asynchronously. Finally, we have the artifacts and streaming. The results are delivered as artifacts. So to improve the user experience, we support streaming. So to expose your agent, simply wrap your standard ADK definitions in the A2A function. This one step automatically configures the executor and generates the agent card from your existing details, making the process practically magic. To consume a remote agent, simply use the remote A2A agent class and point it to the agent card URL. The ADK handles all the communication logic, allowing you to use it in your sub-agents list exactly like a local agent. So you can deploy your ADK agent to Cloud Run or anywhere else, including GKE or Docker, anything. Vertex AI Agent is an enterprise-ready, comprehensive managed platform specifically designed for agentic workflows. It supports other popular agent frameworks like LangChain, LangGraph, other than Google ADK, which provides hooks into any model in the model garden and allows you to bring any tool you need. Crucially, it provides managed service for the hard parts: session management, memory, observability, and evaluation. Cloud Run is an enterprise-ready, fully managed serverless platform specifically designed for deploying containerized application at scale. It supports any programming language, library, or framework, including ADK, provides seamless authentication to Google AI services, and allows you to containerize any system dependency you require. So this is an example multi-agent architecture on Google Cloud, leveraging the Google Cloud's agentic stack. To summarize, we have discussed the Google Cloud's agentic stack covering ADK, MCP, A2A, Vertex AI agent engine for deployment, and the Gemini interface to give a common governed UI interface for all your agents. Right? And this is an end-to-end agent development and productionalization on Google Cloud. Thank you all for your time and engagement today. The key takeaway I want to leave you with is this. We are moving beyond just building isolated chatbots. With this stack, you have all the tools to build scalable, interoperable, and secure agentic systems that can truly collaborate and solve complex problems for your enterprise. I hope you feel equipped to start building your own agents, and we love to hear about what you plan to build next. Thank you.
Good afternoon, everyone, and welcome to our Cloud Technical series. From all the sharing you have heard from my colleagues around AI and all the evolution of AI, I'm sure you agree that we are standing at a massive inflection point. AI is no longer just a feature, it's becoming the operating system of modern enterprises. So before we rush to adopt all these tools, a critical question that arises is that are we safely securing our innovations? I'm Colin Low, and I'm a strategic architect at Google. Today, I'm going to walk you through how we can secure our AI lifecycle without hitting the brakes on our innovation progress and empower your organization to leverage AI with confidence. AI is actually at the heart of all this transformation. 92% of organizations are currently evolving all their IT operations to adopt a modern platforms and technology. Whether you are streamlining your operations for efficiency or chasing after innovation to boost your productivity, the destination is all the same. We're all building towards an AI-ready foundation. All these innovations are all about driving sustained competitive advantage, capturing your new market opportunities, and accelerate your data-driven decisions. Among all this excitement, there is also concerns about what new risks are being introduced. Current landscape is fragmented, we all know that. There are complex security setups, tools inefficiencies, and also a lack of talent and expertise. These complexities are what you are challenged with, and is also the enemy of security. And in the age of AI, fragmentation doesn't just slow you down. In fact, it leaves you exposed. So, how do we keep innovation and transformation secure without introducing new and unknown business risks because of AI adoption? The risk is actually more apparent than before with the rise of agentic, where agents are coordinating together, communicating, and also helping you to solve the higher order problems. These agents operate with very little human supervision. While it gives you autonomy and is powerful, it also introduces new challenges, where risk and security problems are further magnified and pronounced. We must address these security and trust issues before we fully realize their potential. Now, to understand how we can secure these agents, the first thing that we need to think about is let's look into the environment that they all lived in. As AI adoption accelerates, the underlying AI stack continues to grow in complexity. You can't just secure the agent. You have to think of AI as a whole ecosystem with 5 layers beneath that. You have your agent, you have the platform that's running on, the models that you adopt, the data stored, and not forgetting the infrastructure that it relies on. Crucially, we should also be thinking about securing these 5 layers because this has evolved to become your new attack surface. And it is not just a model endpoint anymore. In fact, this complex stack is what you're dealing with today. Reality is, attackers are already finding creative ways to exploit this complexity. We are seeing a whole new spectrum and category of attacks, which we have never heard before in the past. Things like prompt injection. Think of it as, how do I trick the AI to execute something beyond what it should be really doing? What about model poisoning? It's where you secretly tamper with the data that the AI learns from. Data exposure is really, with AI acting as a blabbermouth, it reveals more than what it's supposed to speak about. Things like your private, your sensitive, your confidential information. And this is not theoretical. There are real risks that organizations are concerned about because they are impacting the brand, the reputation, the trust that we have, and also the data sovereignty. Now, if you think of security only as an afterthought, this is really going to be painful because that will indeed slow and stall your innovation. Imagine the rollbacks you have to do because of a failure with your innovation. The decline in trust and confidence that cascades down with it. But if you do adopt an ecosystem that has security in mind, where security is baked in, is embedded by default, and by design, it makes it seamless to adopt security. This helps to become a true enabler of growth for businesses, reducing the friction behind it, and accelerate your digital transformation, and more importantly, your go-to-market. In Google, we built a unified and integrated experience with our Security Command Center, SCC in short. Think of it as a seatbelt for your cloud. It is the foundational security capability for Google Cloud. And if you're running any of the Google Cloud today without Security Command Center, you're actually missing a critical layer of protection, because the controls are built right to the fabric of Google Cloud to help you manage your cloud risks. Among all, SCC does many things. And one of those things that we're going to talk today is really about protecting your AI workloads. Primarily, looking at three different things. Number one, how do you discover where it gives you total visibility of all your AI assets? How do you manage the threats and vulnerabilities in real time? And how do you secure where you safeguard the models and data at runtime? So now, let us break down and starting with visibility. Because you really cannot secure whatever you cannot see. That's the first problem that we are trying to solve with discovery. Security Command Center automatically discovers all your AI assets, be it your agent, your models, your data set across your environment. It builds an inventory that you can exactly see what developers are spinning up and down. That helps you to eliminate any shadow AI issues and risk by giving you a single pane of glass for your entire AI estate. But it goes a lot deeper. We can really scan for multi-cloud data assets to identify your personally identifiable information, your PII, and sensitive data. We will tell you this model is tuned to this specific data set which contains this sensitive financial information. And why is that so important? Because the lineage is critical when it comes to compliance. Now that you know where are all your assets sitting, let's understand the associated risk that is being identified. Within SCC, Security Command Center, there's a part that's called a capability that's called toxic combinations. If I put it in layman term, it means, example, if I leave your front door unlocked and I've decided to post on my social media saying that I'm on vacation, and you start leaving expensive jewelry or money on the table. Each of these might be risky, but they are manageable. But what if they all happen together? It creates a perfect storm that guarantees you a break-in. That's exactly what SCC is looking at. You might have very benign events that comes in, but when it comes together, that's where it becomes an issue that organizations need to tackle. Beyond that, Security Command Center identifies the attack path by conducting what we call a virtual red teaming. It constantly tests and stress tests your AI model to make sure that it doesn't get tricked, to reach out to critical assets and your sensitive data. It gives your team the first-hand information so that you are able to fix all these open doors before attackers can find them. Security Command Center further discover for all the hidden risk and vulnerabilities within your organization before you even go live. Now that we have done with discovery and management, all these are all about posture. What happens if your app is already live? This is where the runtime security comes in. And one of our most exciting innovations from Google Cloud is called Model Armor. Think of it as your firewall to your large language model, LLMs. It sits in the flow of traffic that inspects both the user prompt and the model response. And it eliminates the risk that we earlier spoke about. Things like your prompt injection, your model poisoning. In fact, because of SCC, you can even turn on filters that filter out hate speeches or toxic content. For business leaders, it really helps prevent data loss. So, it stops your fine-tuning of model from hallucinating and leaking of PII information in the response. And for developers and architects on the call, I would like to emphasize the flexibility. So Model Armor isn't just about Gemini. There's a flexible layer that you can protect any model on any cloud. Whether you're calling out OpenAI on Azure, Llama on AWS, or Gemini on Vertex, Model Armor sanitizes all that traffic for you. It allows you to also create what we call a consistent security policy across your entire multi-cloud AI stack through AI posture controls. So you can define what secure looks like. As an example, you can create a rule that says any data that is used for AI training that's in my cloud storage must be encrypted. You might be wondering why. The reality is, in the real world, things change too fast. A developer might accidentally turn off a firewall, or maybe make a private data set public to test something really quickly. SCC, Security Command Center, constantly watches your environment. You can actually see what is changing, the rules that is drifting, and it informs you immediately so you are able to apply the fixes as soon as you can. Finally, we layer on top the best threat intelligence from our Mandiant. So with this integration of Mandiant frontline intelligence onto the platform, Security Command Center can detect for any anomalous behavior that indicates an AI-specific attack. Things like your model theft, your data poisoning. It's really looking at what Mandiant sees in the wild and part of our incident response work. It allows your security operations team to detect and respond to threats that's against your AI workload in real time. Now, I do have a quick demo to show what SCC looks like. It really captures the inventory that we spoke about, providing you your foundational model and data sets. It gives you a risk view, providing your attack path. And for models that you have and decide to turn on Model Armor, how do you apply and mitigate the risk by applying policies like responsible AI? And finally, any kind of anomalous behavior, our intelligence from Mandiant will actually inform you of these. So, to sum things up, securing innovation is imperative to all businesses, and Security Command Center with AI protection offers you the complete lifecycle approach. How do you identify assets and data lineage to our discovery? How do you manage your vulnerabilities and toxic combinations? And apply real-time protection to secure your AI innovation with Model Armor and Mandiant Threat Intelligence. We are helping you to build not just a smart AI, but also a safe AI. It unlocks the confidence across all your various teams. on securing AI, the same way that we secure our own. These are all documented and shared publicly. One of them that I want to point you to is our Google Safe AI framework, which you can actually download through this QR code. Understand your workloads and if they are properly secured. For those who are already very confident, you can really test it by engaging Mandiant to do our red teaming exercises. It gives you an unvarnished truth of your entire AI setup. Last but not least, for any of you who is looking to use AI in your security operations, we have done that many times and we'll be happy to guide you on that journey. And with that, I thank you for your time. So let's go build the future securely. Thank you.